Hi, I'm Brad McKay. This is Incidental Choices Enhance Autonomy, but not Motor Learning and Performance. I'll present the results of a mini meta-analysis from two experiments I conducted as part of my dissertation. Both experiments employed 2x2 factorial designs, with the first factor comparing incidental choice to a yoked comparison group, and the second factor comparing two levels of a scheduling variable, feedback in the first experiment, and practice variability in the second. Both experiments followed pre-specified design and analysis plans. They measured perceived autonomy using basic need satisfaction in sports scale, self-efficacy, motor learning, and performance. These experiments were conducted to test the core hypotheses in the optimal theory of motor learning. In experiment 1, 56 participants completed a golf putting task on an indoor putting surface. Participants were asked to putt the ball from behind a large screen that occluded their vision of results. The experimenter then used a grid overlaid on the putting surface to provide feedback to the participants to assist them in increasing their accuracy over time. The autonomy manipulation in this experiment was to provide choice of golf ball color on any given trial during the acquisition phase, while a second group of participants were yoked to the choices made by the first group. The scheduling manipulation was that of feedback, so the experimenter provided knowledge of results after 100% of trials for half of participants and after 50% of trials for the other half. In experiment 2, 128 participants completed a dart throwing task with their non-dominant hand. The autonomy manipulation was conducted by providing choice of dart flight color to half of participants for any given acquisition block. The other half of participants were yoked to the choices made by the first group. The scheduling manipulation was that of practice variability. So, half of participants were asked to complete a constant practice schedule, throwing all of their darts to the central target only during acquisition. The other half of participants were asked to complete a variable practice schedule, throwing darts to the center target, top left, and bottom right targets during acquisition. The results from experiment 1 are displayed here. The y-axis represents mean radial error, so lower values represent greater accuracy. The x-axis represents trial block. You'll notice that all groups completed a pretest, followed by an acquisition phase, and then completed delayed retention and transfer tests 24 hours later. The results from experiment 2 are presented here, using the same y and x axis. Again, you'll note that all groups appeared to improve their accuracy from pretest to the end of acquisition. A random effects meta-analysis was conducted on these two experiments and revealed that the incidental choices provided in these experiments was successful in enhancing perceptions of autonomy among participants. The Hedges G effect size estimate for this effect is 0.44, or 44% of a standard deviation. Despite being effective at enhancing autonomy, these incidental choices did not enhance motor performance, motor learning, or self-efficacy, as all three measures had Hedges G effect sizes of 0.09, either positive or negative, and all three 95% confidence intervals included the value of 0. Returning to the core optimal theory of motor learning and performance hypotheses that were tested in these experiments, the first hypothesis that incidental choices enhance autonomy was supported. However, the hypothesis that autonomy enhances motor performance was not supported, nor was the prediction that autonomy enhances motor learning supported, or that autonomy enhances expectancies. These results come despite the fact that these incidental choices were effective at enhancing autonomy and thus disagree with the theory in general. I invite you all to join me on Twitter to engage in a deeper conversation of these results. You can find me at BradMcKay8. Stay safe.